Welcome to your virtual field trip. We are so excited to take you to the Department of Energy Savannah River Site for a science lesson. So come on, let's get on the bus.
G'day mates, I'm Kimberly Ficklin and this is Beth Eberhard, and we are from Ruth Patrick Science Education Center on the USC Aiken campus. And today we are at the Savannah River Site where we're going to go down under to figure out the mysteries that are beneath our feet.
So we are standing here in a soil pit. Now this soil pit was dug by a tractor so that you can see a side view, a cross section of the ground beneath our feet. So Kimberly, what can we learn by examining this soil pit?
Well, we're going to look at it layer by layer and figure out what is within and how we use it as natural resources. And we're going to start with the top layer. So the top layer is called leaf litter, and just like litter, it's bits and pieces of things that fall to the ground. So things like bark and acorns and pine cones and things like that help make up the leaf litter. What's underneath the leaf litter, Beth?
Well, here we have this top layer, but wait a minute, we need a compound word to describe the top layer of soil. I know, let's call it topsoil. Now this topsoil layer, you'll notice, is very dark and rich, and it has lots and lots of roots. It has all of these roots, and it's so dark and rich looking because it is full of nutrients. Well, Kimberly, where do these nutrients come from?
Well, we're going to take a closer look at the topsoil, so we're going to take a little sample of it and walk it up to the microscope where we can look at it a little bit better. All right, so we're fixing to take a closer look at the topsoil, and the first thing that I notice is that it is full of bits and pieces. Some are large, some are very small. And we're going to look at texture, and so texture is how it feels. And when I rub it between my fingers, it feels very dry, first of all, but I feel big pieces, and then I feel like a finer particle that sticks to my hands, turns my fingers gray. So we're going to take that and put it under a microscope and see if we can figure out what it is made out of. So I am seeing bits and pieces of things that have fallen to the ground. I'm seeing bits of pieces of leaves, and there's roots right here, and I'm seeing lots of different colors. So there's light browns, dark browns, there's some grays. There is a very, very light, almost yellow piece of that grass that's growing behind the soil pit. Just various colors, and we would call this humus. It's almost the same thing as when you buy potting soil from the store. We are used to it being this dark, rich color. And that's what topsoil is. It's very close to what you would buy when you want to plant something at home.
Hey Kimberly, I know how we can separate the parts of the topsoil. Soil scientists called pedologists use a sifting tower like this one to separate. So as you can see, there are different layers, and each layer has different sizes of screens to catch the different size particles. Okay, so I'm going to go get a sample of soil from an undisturbed layer, and then we're going to sift it to see what's inside.
Okay.
Okay, Kimberly, let's take a look and get a sample of our topsoil. I'm going to scrape off all of this leaf litter, okay, and get a good scoop of this topsoil. All right, that looks like enough. I'll put the lid back on. And now we're gonna shake it like an earthquake. Okay, let's see what we've got, Kimberly.
Okay.
Open up each layer and set them out. See what's sifted through each one of them. Wow, look at the difference. So in this top layer, I see lots and lots of big chunky pieces of bark. There's a leaf. There's some roots in there. Pine needles, but look at this next layer.
Yeah.
Much finer, but still you can identify the roots, the little bits of pine needle. Okay, there's some leaves in there. Oh my goodness, look at this.
That's cool.
Wow. That is some good, rich topsoil right there.
Yes.
So, Kimberly, what's going on here?
Well, what we have is, and what is so cool about it is everything that you're looking at here is topsoil, and it's part of topsoil. So the top layer right here, once it gets weathered over time, it becomes what is in the second layer, and the second layer continues to get weathered and becomes what is in the third layer, which is what looks like soil to us, like something that you would plant something in. And so when these things are falling from the tree has used nutrients out of the ground to make these things, to make pine cones and leaves and pine straw. Those things fall to the ground, they don't lose the nutrients, they simply fall apart and add nutrients back to the ground. And so it's nature's recycling program. Once was big pieces and chunks of living things become part of our topsoil. And so let's go dig and see what's under the topsoil, Beth.
Okay. So here we are back at the soil pit. Now we've already talked about the leaf litter and the topsoil, but let's look at this second layer. Okay, look how sandy and gritty this is, and it feels just like beach sand. Well, how did this sand get here? Well, millions of years ago, this land looked very different than it does today. In the upstate of South Carolina, of what is now South Carolina, ancient times, there were the Appalachian Mountains much, much taller than they are today. And as these mountains weathered through wind and rain and ice, the rocks would break off, and as they broke off and rolled down the hill, they would create sediments, and those sediments were carried through erosion down through the streams and rivers until they hit the ancient ocean. Well, where we're standing today was the coastline of that ancient ocean. And in that ancient ocean, well, this was beachfront property. So we had all of this sand that was deposited here from wind and rain, and it formed these sand dunes. And these sand dunes went from Georgia to South Carolina through the middle of North Carolina and formed a belt that we called the Sand Hills. So here's a map that shows the Sand Hill region of South Carolina, and that's exactly where we are today. And so this sand layer that we see here is actually coming from the Appalachian Mountains in upstate South Carolina. How cool is that?
Pretty cool. Very cool. So we're going to go ahead and take a sample while we're down here of the soil layer, the sand layer, and take it back up to the microscope and compare it to topsoil. All right, so now we're looking at the sand layer, and the first thing I notice is the color, of course. So the color is very, very different from the topsoil. It is more of a light tan color, and the grains, I can go ahead and see that, are a little bit different. They're more jagged, but pieces that look like mainly rocks. And so I'm going to put that under the microscope and see what other colors I see. So every once in a while I am seeing like a gray in there, but for the most part it's like a light brown color, and the grains are real jagged and they're rock-like, okay? So they look like little pieces of rock, which they should, because of what Beth showed you earlier. I'm not seeing any of the humus, no leaf litter at all. So there is no like nutritional value in here for the plant life. And so you have to kind of wonder, well, what good is sand for us? It is a very important natural resource. Other than making sandcastles and filling up sandboxes, we make concrete out of sand. We also use it for tops of shingles that go on your house, and we use it to make glass. We also put it on roads for traction in the wintertime so that we don't slip and slide around. So it is a very important natural resource.
Okay, so we have talked about the topsoil. We've talked about the sandy subsoil. Let's go take a look at what's down under. Okay, come on. All right, well, we're back here at the soil pit. You can see the distinct layer of topsoil, sand layer, and look at the distinct color change right here. So we have some very interesting colors here. We've got some oranges, yellows, and whites. This is actually a clay layer. So you've got different colors of this clay because of the different mineral content. So that orange layer, that orange color has a little bit more iron in it. The white is actually a type of clay called kaolin. And notice, this is very fine. It leaves a very fine feel to my hand, very powdery, and it sticks together. See how wet it is? It sticks together when I push it in. Okay.
All right, so let's take a sample of that. This layer is a little harder, so I kind of have to shave off some pieces and put it in a petri dish for us to look at a little closer. All right, so we're gonna look at the clay layer just a little bit closer. Like Beth, the first thing I noticed is I'm dealing with two different colors, okay? An orangey color and a light, almost gray color. So let's put it under the microscope and just see what we can see. So the first thing I noticed right off is the two colors that we're seeing, two very distinct colors, an orangey color and a kind of a light gray color. So very different colors and considered two different types of clay. Clay is made by two ways, not like sand in that it's just the mechanical or the physical weathering. It's going through also a chemical weathering as well. The other thing is the clumpiness of it, which Beth showed you. When it's wet, it's able to be molded, and that's because the grain sizes are so tiny. They like to stick together. And so that's the main thing I'm seeing is a lot of clumpiness here, and it's mainly because this soil is wet. So we do have regular clay here. This is kaolin clay that has dried out, okay? So it looks more like a powder, and you can see that it is very powdery. And that the grains under the microscope, because they're wet, they're very clumpy, but we can actually take some of that and spread it around or use this. It does work like chalk. Okay, so the grains are super fine.
It's like powder.
And as a natural resource, we use it for all kinds of stuff. So it's used in making magazine covers, the glossiness of it, even the pages within it. The glossiness comes from that kaolin ingredient. We also use it to make fine china. It's also used in making toothpaste and in makeup. The orangey kind of clay, we make into bricks and we mold it into things like pottery. And here is a pretty little tile that is made out of clay.
So Kimberly, folks have been making pottery out of clay for thousands of years. American Indians have made pottery from clay, and you can sometimes find pieces of this pottery in the soil when you dig down into the soil. But here at the Savannah River Site, archaeologists have made an amazing discovery of a very interesting piece of pottery when they were making a dig. Let's learn a little bit more about that.
Okay.
Hello, my name is George Wingard, and I'm with the Savannah River Archaeological Research Program located here on the Savannah River Site. And what I have next to me here is a jar that was found during archaeological excavations here on site in 2006. This particular jar, when found, had been busted into 19 pieces, and we placed it back together. It weighs about 18 pounds. So who exactly made this jar? Well, his name is right on the front, Dave. Dave, we know, was born a slave. He was a potter from Edgefield, South Carolina. We know from records he was born about 1801. Also on this, inscribed on this particular jar is LM, which stood for Lewis Miles, and the date's April 16, 1862. Dave wrote this himself, so he knew how to read and write. He also wrote things like inscriptions on the jars. He wrote little poems. One poem in particular says, "O moon and stars, it's hard work to make big jars." He also wrote a poem that says, "Blow the fife and beat the drum. The 4th of July has surely come." When you see jars like these, most of them are either going to be in private collections or in museums. This is the only jar that's ever been found in an archaeological context. So we're pretty proud of this little jar. We're proud that we were the ones who found it. And over the last few years, it's become quite the celebrity in its own right.
So Kimberly, we've talked about the differences in clay and sand, the particle size differences, but I wonder how that affects the drainage rate, how much water will flow through. So I have set up a little science experiment. So we have 2 flasks, and inside each flask I have put a filter inside, just like that. And in each filter I have put a little bit of the same amount of clay in this one, and the same amount of sand in this one. So we want it to be a fair test, okay? All the constants are the same except for one, which is our manipulated or independent variable. And that is the amount or the type of earth material, clay and sand. So I'm gonna pour the same amount of water. I've got some colored water here. It's 20 milliliters of water. I'm gonna pour it in, give it the same amount of time. We're gonna count down from 10. And see how much water drains through within 10 seconds. And that will be our responding or dependent variable. So here we go. Okay, pour it in. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. And let's take out those filters and see how much water has drained through. So if you will pour that water from the sand into your graduated cylinder. Okay, and we will see what our responding variable is. This is our responding or dependent variable. And we can see that we have very little water that drained through that clay, but about 19 milliliters, 18 or 19 milliliters drained through the sand. Well, why is that? Let's think about what we know. So we know that the particle size of sand is much larger, and we also know that clay tends to clump together. So I've got a model here that will help understand that a little bit better. So this is the model of sand, the particles of sand, and you can see there's big holes in there, and those big holes allow water to drain through. So there's a lot of pores for the water to be able to find a way down to the bottom. On the other hand, this is a model that shows the particle size of clay, and you'll see that the pores or those holes are much smaller. It's harder for the water to find its way down, and we know that when clay gets wet, it clumps together and it forms a barrier to the water going through. So what does this all mean? Well, if we have different types of soil, different amounts of clay and sand, we're going to have different drainage rates, different amount of water that can travel through. Okay, so let's take another look. Let's take a final look at our soil pit.
Okay. All right, so Beth, we've looked at all the layers that we have here at the Savannah River Site, and we've seen differences everywhere. We've seen differences in the color and the texture and the size of the grains, and even the permeability rate. And so all that affects what can live in this type of habitat. Because you have a lot of sand here in the sand hills, it allows for a very dry habitat. And so the longleaf pine that you see behind us, as well as all of the grasses that you see and the prickly pear cactus, all live right here in this type of habitat. And because of that, that also affects what kind of animals can live here. So the bobwhite quail and the gopher tortoise, as well as the red-cockaded woodpecker, it's all connected. So what you see around you here on top of the soil and what we have below the soil is all very connected, and it all begins down under.
So thank you for joining us here at the Savannah River Site as we explore the mysteries of soil beneath our feet.
Cheerio,
Cheerio mates!